At question 5 right here, I want to evaluate the limit as x approach this of this function right here. Now we don't know already, we have two ways to do that question. So going to right here, we're going to evaluate this limit. Method 1 is L'Hopital's rule, L'Hopital rule, where we differentiate the numerator and differentiate the denominator. L'Hopital rule or L'Hopital rule, however you want to pronounce it. This is just going to be the limit as x approaches 3 off. When you differentiate the numerator, you get 2x divided by, when you differentiate the denominator, you get 3x squared. Now, one thing we realize is say, this x right here, so can cancel out the x from the denominator. So can end up just get the limit as x approaches 3 off. The x in the numerator cancel out the x in the denominator, so it's 2 over 3x. Then you plug in x as 2, you get 2 over 3 times 2, and 3 times 2 is 6, so you end up just get 2 over 6, and 2 over 6 is 1 over 3. Now, if you're doing it the other way now, you're going to have to break this up as the limit as x approaches 3 off. You see 9 is really 3 squared, so we can use difference of 2 squared and write this as x minus 3 times x plus 3 in the numerator. And then in the denominator, we can factorize x cubed minus 27 as x minus 3 multiplied by, this is then x squared plus 3 times x, which is plus 3x, plus 3 squared, which is plus 9. If you don't believe me, expand back x minus 3 times x squared plus 3x plus 9, you're going to get back this. Then the x minus 3 them cancel, and then you can plug in as x approaches 3. Then you plug in your 3 now, you get 3 plus 3 divided by, plug in your 3 square plus your 3 times 3 plus your 9, and you're good to go. So what you get is 3 plus 3 is 6. So you get 6 over, this is 9 plus 9 plus 9, which is 27. And 6 over 27, 3 into the, well, wait, we get 3 squared is 9. Yeah, we get 6 over 27. We didn't get 6 over 27 here. We got 1 over 3. What's 6 over 27? Let's pop out our calculator. 6 over 27. That's 2 over 9. So something is off. We didn't get 2 over 9 over here. Let's look at why. This is 3x squared. This is 2x. And x gone. And x gone. 2 over 3x. Oh, x was 3. So may I change up the question? Because this is giving 2 over 9. So I have to focus 2 over 9. And this right here was x as 3. 3 times 3 is 9. This is 2 over 9, which is, yeah, 2 over 9. So just for pretty it up now, it should have been 2 over 9. All right, so we'll get the same answer. That was the own thing. That's why I like to do it the two ways, them at the exam, to show say the same answer. So that's part 1, we get 2 over 9. So this work out to be 2 over 9. All right, nice, 2 over 9. Now the next part now is to evaluate this limit right here. To evaluate this limit now, first thing we can do is use L'Hopital's rule again. Using L'Hopital's rule, so we're going to split the page. One side is L'Hopital rule and the next side is trig identity. So over here now, what you're going to end up get is, using L'Hopital rule, this becomes the limit as x approaches 0 of, when you differentiate tan, you get sec squared. So we get sec squared x, we differentiate 5x, we get minus 5. Divided by, or differentiate sine, we get cos. So we get 2 cos 2x, Or differentiate 4x, we get 4. Now you plug in x as 0. When you plug x as 0, you're going to get now sec squared 0. What is sec squared 0? Sec is 1 over cos. So I'm just going to put it in 1 over the cos of 0 squared. This is sec squared. Let's put in the 2. That's 1. 1 over cos squared. So sec squared is 1. So when I plug in 0, I get 1 minus 5 over the cos of 0 is 1. So I get 2 minus 4. This is going to work out to be negative 4 over negative 2. And that can end up giving me 2. We're doing it the alternate method now, that is L'Hopital rule, or you can do it by factorization, well not factorization, by applying sine x over x equal 1. By applying that, look what we're going to do. We're going to break this up as tan x minus 5x over sine 2x minus 4x. To do this limit now, what we're going to do is first, we're going to have to multiply the denominator and the numerator by 1 over x. We're going to multiply the denominator and the denominator by 1 over x. By doing that, what we're going to end up get is the limit as x is clearly approaching 0 of. This part going to become tan x over x. Then we're going to have minus 5x over x. That going to just be minus 5 divided by, this is then the limit of sine 2x over x. And then we're going to have minus 4. Now what we're going to do now is look at this. We're going to put a 2 right here, so, and put a 2 here, so. Because guess what? We know that the limit of tan x over x is 1. That works out to be 1 minus 5 over the limit of sine 2x over 2x is 1. This is now 2 times 1 minus 4. Applying that part, now we get negative 4 over negative 2, which is still 2. So anyway you take it, you get the limit for be 2. See it there? Nice. That's it. We get 2. So we can tell them, so this work out to just be 2. Alright, nice. Now continuing now, this part right here, so now, them say, this is our function f of x. Find the limit as x approaches 4 from the right hand side. When it's a plus, they're talking about the right hand side. So find the limit as x approach 4 from the right hand side. From the right hand side, we'll plug in x as 4. That is the bigger part. So we can tell them the limit as x approaches 4 from the right hand side of f of x is just going to be equal to plug in 4 on the bigger side when x is greater than 4. So we're going to plug in 4 in this equation to get 1 plus 2 times 4, and that equal 8 plus 1 is 9. That gives 9. So the limit from the bigger side is 9. All right, so this side we end up get 9. Now what they want us to do is work out the limit from the left now. The limit from the left. This is part 1. So to work out the limit from the left now, which is part 2, you're going to plug in 4 in the other equation for f of x. So the limit as x approaches 4 from the left of f of x, that's going to be equal to, plug in the 4 in here now, we're going to get 3 times 4, which is 12, minus 7, that is 12 minus 7, which is 5. So this equals 5. So since the limit equals 5, that's it. So clearly we can see the function don't continuous in a case like this, because we end up get this equal 5. Now them say deduce that the function is discontinuous. It is clear that it is discontinuous since the limits are not the same. So all you have to tell them is, since The limit from the left don't equal the limit from the right. So this is you write it in symbolic form. Since the limit as x approaches 4 from the left of f of x is not equal to the limit from the right. Say right, not equal to, since the limit from the left is not equal to the limit from the right, therefore f of x is not continuous. All right. And so therefore we just write that, therefore f of x is not continuous. And that's it, f of x is not continuous. Nice. Now since that is that now, we deduce that it is not continuous at x equal 4. All right, therefore f of x is not continuous. You have to tell them at x equal 4. All right, and the ultimate reason is because the limit, basically what we're saying is the limit as x approach 4 does not exist. In other words, if you want to write it this way, this is also fine. The limit as x approaches 4 of f of x does not exist. Why it don't exist? Because the limit from the left don't equal to the limit from the right. All right, that's it. Easy. All right. The next part says to integrate this function right here from -1 to 1 of x minus 1 over x squared dx. Easy question. This is what they want us to integrate. The first thing you have to do is expand. Once them give something with square, expand it out. It's first term square minus twice the product of the two, minus 2 times x times 1 over x plus the second term square plus 1 over x square all square. This is what we end up integrating dx. I know I'm writing Hilangoli, but that's fine. So what this works out to be is the integral from -1 to 1 of x squared. Now this x cancels this x, so just have -2. Then this becomes 1 plus 1 over x squared. But you see that 1 over x squared right there? You can rewrite it as x squared to the -1. Yeah, man, you can write it as x squared to the -1. So this is now the integral from -1 to 1 of x squared minus 2 plus x to the -2. All right, by writing it this way, it make it easier to integrate. Yeah, man, it's easier to integrate this way, dx. Now, when you get this answer right here, so now, what we're gonna do is integrate it. So this is gonna be equal to now, add 1 to the power x cubed divided by the power 3. Minus, add 1 to the power 2x. Oh, good, then we add 1 to the power, which become plus x to the -1. Divide by the power of -1. All right, and then of course we plug in from -1 to 1, -1 to 1. Now when you plug in the 1 then on this side, right, what you're gonna get is plugging in the 1, you get 1 over 3 minus 2. Then this here so now is when you plug in 1 right here, so this is 1 to the -1, which is 1. 1 over -1 is -1. So that's when we plug in the 1. Minus, plug in -1 now. -1 cube, that's -1 over 3. Put -1 here, so you're going to get +2. Then when you put -1 here, so -1 to the -1 is, just to be safe, I'm putting it in my calculator, -1 raised to the -1. That's -1, and then I divide it by -1. So I'm going to get +1. And so that will equal to, as I can see, the 1 over 3 minus 1 over 3 minus 1 over 3, that becomes 2 over 3. Then the -2 minus +2, this becomes 1 over 3 minus 2 minus plus 2, that become minus 4, and then negative 1 minus 1, that become negative 2. So I can just work this out now. That's negative 6, so that's 2 over 3 minus 6, and so that becomes, I multiply up the 3 up here, that's 18. 2 minus 18, 2 minus 18 is minus 16 over 3. So I get negative 16 over 3, or maybe some would put as minus 5.33. So just to verify that I didn't make any calculation error or any bloopers, what we're going to do is bring out the calculator and do it. We're going to integrate from minus 1 to 1 of, this was in bracket x minus 1 over x, just to make sure we don't make no mistake. Close up the bracket, then you square it. This calculator can't perform that. All right, as you can see, the calculator is unable to perform. Well, we can see that the calculator never too sure what going on, so we're just gonna make sure so we never make a calculation mistake. So we get negative 16 over 3. All right, that's that. Now this one right here now says, by using u substitution, find the integral of this. This is so boring. This is really boring. So if you're doing u substitution, and all we're going to do is substitute u as the x squared plus 4. It's really boring. So if u is x squared plus 4, right, then what you know is that du dx, if you differentiate u with respect to x, you would get 2x. So if you cross multiply the dx, right, you're going to end up get du is equal to 2x dx. Now look at this. If you make dx the subject and divide through, if you divide through by, well, let's divide through by 2, right? If you make x dx the subject, you get a half du gonna equal to x dx. All right, so if a half du equal to x dx, what we end up get is this gonna be equal to the integral of, this become now the square root of, now look what I'm gonna do. Write the x dx together. So I'm gonna rewrite this as x squared plus 4. Then I put my x dx together. Put my x dx as one thing. When I put my x dx as one thing, you see this now, this part right here, so can rewrite that as half du. So this can end up equal to now the integral of, remember, we substitute this part as u. So that is now the square root of u. And then the x dx right here, so see x dx here is a half du. So we can replace this now with a half du. Yeah, man, oh nice. So now we can go ahead and just integrate normally now. This is going to be equal to, factor out the half, it is the half of the integral of u to, instead of writing square root, put u to the half, du. They will know how to integrate together. We add 1 to the power and divide by the power. So that becomes add 1 to the power, u to the 3 over 2. Then we divide by the power of 3 over 2. Now put plus some constant c. If you're dividing by 3 over 2, you're multiplying by 2 over 3. 2 over 3 times a half, when you work that out, 2 over 3 times a half, 2 over 3, it's going to be 2 over 3, it's going to become 2 over 3, 3 times 2 is 6. That actually work out to be 1 over 3 then. So this is going to work out to be 1 over 3 times u to the 3 over 2 is u cube being square rooted plus some constant c. But then what was u? U was x squared plus 4. So this is going to work out to be 1 over 3, the square root of, this is now x squared plus 4. Oh, good. It's 1 over 3 times the square root of x squared plus 4 plus a constant c. And that's it. Nice. All right? We don't have nothing to worry about. Nice. And that takes care of question 5. Can just put that here, so we're done. 1 over 3 times the square root of x squared plus 4 all cubed. Nice. Plus a constant c. Oh, good. Nice. Oh, I left off my cube here, so don't put on my cube. All right, that's it. Nice. Easy. All right, now on to question 6. It's if we differentiate this now with respect to x, y equal to sine of 3x plus 2 plus tan x. There's nothing really to this. If we're differentiating this, you have to remember that when you differentiate sine, you get cosine, but then you multiply it by the derivative of what's in the bracket. When I differentiate that 3x plus 2, I will get 3. When I differentiate sine, I will get cos. So it's going to be 3 times the cos of 3x plus 2. Then when I differentiate tan 5x, I know that I get sec squared. This is going to be plus 5 sec squared 5x. Oh, good. That's it. And you get your full 3 marks just for that. All right, that's that. Nothing to it. 3 marks. Soft. With a capital T. You have to tell them, you have to tell them, say this soft. Soft. Capital T. Now this one right here, y is x squared plus 1 over x cubed minus 1. To use quotient rule to differentiate this, you remember, you start with the bottom and you end with the bottom square. So it's going to be x cubed minus 1, start with the bottom, times the derivative of the top, which is 2x. Then you minus the top. The top is just the x squared plus 1, multiplied by the derivative of the bottom. The derivative of the bottom is 3x squared, and this is all over the bottom square. Over the bottom square. This is x cubed minus 1 all square. So that's what you have. Nice. So all we need to do now is to just simplify this. So simplifying this now, what we're going to get is dy by dx is going to be equal to, you just need to expand in this, 2x times x cubed, that's 2x to the 4, minus 2x times 1, that's minus 2x. And I'm not writing it so clear, so that's minus 2x. Minus, now 3x squared times x squared, that's 3x to the 4. Then 3x squared times 1, that's going to be minus 3x squared. They might wonder why minus. Minus because this minus times the plus become minus, and minus 1 times this becomes minus. All right, and it's being divided by x cubed minus 1 all squared. All right, nice. So when we work it out now, what we're going to get is, you just need to group like terms. 2x to the 4 minus x to the 4, that is just minus x to the 4. So that's minus x to the 4 minus 2x minus 3x squared. So you can write minus 3x squared minus 2x over x cubed minus 1 all square. Now they didn't tell us how to simplify. They didn't say to factor out the x or nothing. So I would leave it like this, right? Leave dy by dx as this. Leave it as this. I may have time for factor out x and all of that, but may I try to done the paper and get distinction, right? So we don't have time for this, so leave it right there. So, all right. The next part is it tells us that the function f of x satisfies this. The integral from 1 to 4 of f of x is 7. So find this integral right here. To do that question now, right here, so now they give us this, the integral from 1 to 4 of f of x is 7. So we need to find this. To do this now, what we're going to have to do is first, we can break it up as two integral. This is the integral from 1 to 4 of 3 times f of x. Then we're going to have plus the integral from 1 to 4, of 4 dx. All right, that's what we're going to have. Nice. Now we can factor out this 3 right here. So now we can factor out the 3, and then we'll have the integral from 1 to 4 of f of x. We'll factor out the 4, and we'll have this now, the integral from 1 to 4 of f of x dx. And then you have plus the integral from 1 to 4 of 4. All right, integral from 1 to 4 of 4 dx. Now remember, the integral from 1 to 4 of f of x we already established at 7. So this is then 3 times 7 plus, we just need to work out this part now. When you integrate 4, you get 4x, but we're integrating from 1 to 4. So just need to plug in from 1 to 4. So what we're going to end up get is, when you plug in the 4, you know you're going to get 16. So this is going to be 3 times 7 is 21. Plus, over here, so now going to be 4 times 4 is 16, minus 4. 16 minus 4 is 12. 12 plus 21 is 33. So that's what that work out to be, 33. That easy, 33, well nice. This is 33. Now that this equal to 33, let's do this part now. Using u substitution, evaluate this integral. All right. Now this is what we need to do, but going back around here, this is f of x. If we're supposed to use u as x plus 1, let's see what they're telling us. If this is u, right, then what I know then is u minus 1 would be equal to x. And if this is also u, that would imply that when x equal to 1, when x is equal to 1, that would then tell me that u is equal to, let me see, when x is 1, if I put 1 right here, 1 plus 1 is 2, but they have a 0. All right, so this is what we have now for, this is u now, u minus 1 is x. And then if I differentiate it, I know that du is going to be 1 dx. All right, let's see how we're going to substitute u as that now. Because we want, what do we want to find? We want to find 2 times f of x plus 1. So in reality, if we're integrating from 0 to 3 of f of x plus 1, right? If we're going to substitute u as x plus 1, then that means that if this is u, oh, look, they changed the limits, all right? They changed the limits. So if this is the limits now, when x equals 0, actually, what we're going to get is u is 0 plus 1, which is 1. And also, when x equal to 3, what we're going to get is u is equal to, put 3 right here, so 3 plus 1 is 4. All right, nice. So now we can tackle that part of the question now. So now this is going to become now, replace x plus 1 with u. So this is going to become the integral from when u is 0, when x is 0, sorry, u is 1. So it's integral from 1 to 4 of f of x plus 1 becomes f of u du. So that's what we have right here. But the integral from 1 to 4 of f of u du, that's just going to be equal to the same 7. That's it. This is just 7. You're not doing anything, right? That's all, right? This is just f of u du. They're not asking us to do anything. Not at all. Let's just work out. Oh, they didn't want this. Then this would be this answer right here. But what the question actually wanted was 2 times it. So therefore, the integral from 0 to 3 of 2 times f of x plus 1, since it's 2 of it they want, we didn't multiply it by 2, right? You're going to end up saying that this is now 2 times 7, and 2 times 7 is 14. So this is now 14. That's the final answer, 14. All right, nice. So we almost leave off that part, but quickly we realize that this is 14. Nice. All right. Now the next part that they want us to do now is, it tells us you have a curve and you have a line, find the points of intersection. For 5 marks, oh, them so nice. All we have to do first is substitute the line into the curve. So remember, we just find this was 14. Now we need to substitute the line into the curve. All right. Yes, in the diagram below the line, x plus y equal 2 intersects the curve y equal x squared at the point P and Q. Find the coordinates of P and Q. So all we need to do is solve a simultaneous equation. We're just going to solve a simultaneous equation. We're going to rewrite y as 2 minus x, and then the curve is x squared. So we can solve them simultaneously easy. Y is equal to x squared. And we also have y is equal to 2 minus x. So since y is 2 minus x and y is x squared, the two of them together is really saying x squared is equal to 2 minus x. So we can just bring over the 2 minus x over to the left, and that's going to become x squared plus x minus 2 equals 0. And if this is equal to 0, we can factorize it. So factorize it now, equals 0. So that's what we do here. And this is going to be x and x. This is now 2 and 1. And it is saying signs are different, the greater product is positive. So this one have the plus and this one have the minus. So what we're getting is x is equal to 1. I don't write this like a x. Come fix this up. Make it look a little better. X equal 1 and x is equal to negative 2. But remember, say y is x squared. So if you put in 1 square, you're getting that you get this value is also 1 for the y. And if you put in negative 2 square, you're going to get 4. So that means that the points are 1, 1 and negative 2, 4. 1, 1 and negative 2, 4. All right, that's what we have. Nice. So we can put it on the graph right here, so, and tell them, say, what is P? P at the negative 1, P at the negative 2, 4, and they can tell them, say, Q at the 1, 1. Q at 1, 1. Nice. Now, next thing them ask us to do is calculate the area of the shaded portion bounded by the curve and the straight line. So we need to find this area shaded right here. So to find this area shaded, it's going to take a lot of work, because remember, you notice that right here, so the curve right here, so we're going to have to integrate from here to here, then from here to here under the curve, but at the same time the line is here, so we need to also think of the area under the line. That's a lot of work. So what I'm going to do is I'm going to break it up in a way that might reduce the amount of work that we have to do. And I'm going to break off here as a triangle. I'm going to call this portion that I'm about to shade A. This portion here is A. I'm going to call over this portion right here. So I'm going to call over this portion B. So pretty much this is a big triangle, and the area of the big triangle what I'm saying is area of the triangle. You notice that the area of the triangle is equal to A plus the area shaded that we want plus B. So all we need to do is find out what is A and what is B. Now the area of this big triangle right here, so the height would be going up to P, that's 4, and the base would be from the x value of -2 straight over to this x value, and this x value is the line x plus y equal 2. Then I would know that the x value here, the y value is 0, x is 2. This is 2. So this is from -2 to 2. So this is also a base of 4. Now clearly this is not drawn to scale because this is 4, the base is 4. So the area of the big triangle is a half the base times the height. So it's going to be a half the base of 4, half of 4 times the height of 4. And then that's the area of the triangle. And if I subtract A and I subtract B, that would give me the area shaded. So the area shaded is that right there. So a half of 4 is 2. 2 times 4 is 8. So it's 8 minus in bracket the sum of A plus B. So what we're going to do now is go to the whiteboard and work out what is A and work out what is B. Let's just go ahead and do that and have some fun. Now to work out A, we're just going to integrate the curve from -2 to 0. That's going to give us A. Area under the curve is integral from -2 to 4 of the curve x squared. So let's do that. So going right here now, we're going to realize that A is equal to the integral from -2 to 0 of the curve x squared dx. So we're going to integrate now, and when we integrate that, A is just x cubed over 3. I'll plug in our limits from -2 to 0. -2 to 0. Plugging in 0, that's going to be 0 minus in bracket -2 cubed is 8 over 3. That's when I plug in the -2. -2 cubed is actually -8. So in this case, it works out to be 8 over 3. That is A. So now we just need to find out what is B. Now B can be a little bit more complicated. Looking at the diagram, we can see that B, we have to integrate the curve from 0 to this point. So integrating from 0 to Q, which is 1, and then we integrate the line. You might say, what? Yes, to find B, we have to integrate the curve, because we need area under the curve. We have to integrate the curve from 0 to 1, plus then integrate the line from 1 to 2. So we're going to integrate. So for B, it's the integral of the curve from 0 to 1 of x squared dx. And then we have plus, we integrate now, integrate the curve, and then we integrate the line from 1 to 2 of y was 2 minus x. So 2 minus x dx. Without further ado, let us go ahead and work this out. So what we're going to get is, we get x cubed over 3, and the limits, we plug it in from 0 to 1, plus, right here, so now we integrate, we get 2x minus x squared over 2. I'll plug in the limits from 1 to 2. So plugging in the limits them now, plugging in the limits, that's going to be equal to, plugging in the 1 here, we're going to get 1 over 3. When you plug in 0, you're just going to get 0. So that's 1 over 3 plus. Plugging in the 2 now, if you plug in 2, 2 times 2 is 4. Minus 2 squared over 2 is 2. That's minus 2. Close that now. Subtract, when you plug in 1, you get 2. Minus, when you plug in 1 now, you get 1 over 2. Close up that. That's equal to 4 minus 2 is 4 minus 2 is 2, so I get 1 over 3 plus, this is now 2 minus this part right here, so 2 minus a half is 3 over 2. 2 minus 3 over 2 is negative a half, no? 2 minus 3 over 2. So 2 minus 3 over 2 minus a half is 3 over 2. Minus and minus make this become plus. And then 2 by itself is really 5. 2 by itself is 4 over 2. So 2 plus 3 over 2, that is really 4 plus 3 is 7 over 2. So it's 1 over 3 plus 7 over 2. And 1 over 3 plus 7 over 2, if my math serves me well, 1 over 3 plus 7 over 2, that is, all right, I'm just going to take out my calculator. So I take out my calculator. That is 3 times, that's 23 over 6. 23 over 6. Nice, so we'll get 23 over 6. Now, if B is 23 over 6, what we really need is A plus B, right? So that means if we can write right here, so A plus B is going to be equal to 8 over 3 plus 23 over 6. Yeah, add up them, the 8 over 3 plus 23 over 6. We end up get 6.5. So all of this add up to be 6.5. 6 and 1 over 2. That's A plus B. So going back around here now, this is, oops. That came off the screen real quick. Let me go back again. That's 6.5. All right, so that's 6.5. So this is 6.5. So that means that the area shaded then is going to be equal to 8 minus the 6.5. And then when we work that out, what we end up get is 8 minus 6.5. That's 3 over 2. That's the area shaded. Nice. Of course, you know, so you have to tell them the answer is in units square. The answer is units square. And that's it. Nice.